In our look of solving equations so far, we have looked at simple one-step equations and then multi-step equations. But one thing that all these have had in common is that the variable has always been gathered or has always existed only on one side of our equation. In this lesson, we're going to take a look at what happens when the variable does show up on both sides. Now, to look at this, we're going to start by taking a look at a general method and steps for solving. Now, it starts out the same as what we've had in the past. And that is that we're going to distribute over any parentheses that we see, and when we're done with that, combine like terms. But if we do have the variable showing up on both sides, our next step will be to gather all variables to one side. Now, the way we're going to do this is we're going to treat the variable as if it were a normal number. So if we have a positive 2x on one side and we want to get rid of it, we're going to subtract that 2x. So we're going to move variables through addition and subtraction the same way we use our normal numbers. Now, after all of our variables are gathered to that one side, we're going to use SADMEG to solve for the remaining variable and then check the solution. And again, that check can be verbal, or it is actually much preferred for it to be a written check. So we'll show that today. Now, let's work through a couple of examples to see how all this will play out as we do it. Our first equation will be 6 plus 3x equals 9x. Now, in order to solve this, we're going to run through our steps. Do we have anything to distribute? No, we don't. And we also don't have like terms to combine. Now, some people will look at an equation like this and say, hey, here's a 3x and here's a 9x. Aren't those like terms? Yes, they would be, except like terms means that they have to be on the same side of the equal sign already. Next, we're going to gather our variables to one side. So the way we do this is we're going to get rid of the smaller number. That is preferred because then we don't have to worry about negatives. But you see in this instance, this 9x is already isolated, whereas the 3x has the positive 6 constant with it. So we're going to move everything over to this side, meaning I have a 3x here that I need to get rid of. And the way I can best do that, since it's a positive 3x, is subtract 3x from each side of my equal sign. Now, on the left-hand side, that leaves me with just 6. On the right-hand side, that will leave me 9x minus 3x is simply a 6x. Now what do we do to move forward from here? Let's look at step 4. We follow SADMEG. Do we see any subtraction or addition in the remaining equation? No, we do not. Do we see any division or multiplication? Yes, 6x means 6 times x. So we're going to divide both sides by 6. And that leaves us with 1 equaling x. Now, how can we make sure that this is the correct answer? Well, that is done through checking. So 6 plus 3 times 1 has to equal 9 times 1. So 6 plus 3 has to equal 9, and sure enough, 9 equals 9. This one checks out. So simply substituting back in and simplifying both sides of the equation, make sure that they are equal, acts as our check. Let's take a look at another equation to solve. Our equation, 5x plus 2 minus x equals 5 minus 6x plus 1. So we're going to start by distributing, which we do not have any of. Next, combine like terms. On the left-hand side, we have a 5x and a negative 1x. When I combine those, I get 4x plus 2 is equal to, on the right-hand side, I have this positive 5 and the positive 1, giving me 6 minus 6x. Next, gather all variables to one side. On the left-hand side, I have a positive 4x. On the right-hand side, I have a negative 6x. Since all negatives are automatically smaller than positives, I'm going to get rid of that negative 6x by adding 6x to each side. This tells me that 10x plus 2 equals 6. Now, we follow SAD-MAG. Do we see any subtraction or addition? Yes, we have a plus 2, so I'm going to subtract 2 using inverse operations. So 10x equals 4. Next, do I have any division or multiplication? Yes, I have multiplication, so I'm going to divide both sides by 10. And I end up with x equaling 2/5. For sake of space, I don't have enough here to do another example and check that, but be sure that when you're doing your work that you check your solutions. Our next equation will be 3 times the quantity 3x minus 4 is equal to 1/4 times the quantity 32x plus 52 plus 1. Now, we're going to run through our method. First, distribute over parentheses. So 3 times 3x and 3 times negative 4 gives me 9x minus 12 equal to, if I distribute this 1/4 times 32x and 1/4 times 52, well, 1/4 times 32x will be 8x. 1/4 times 52 is 13. Then add my 1. Step 2, combine like terms. On the left-hand side, I don't have any to do, 9x minus 12. On the right-hand side, however, I can add this 13 and 1 together, giving me 8x plus 14. Next, gather all variables to one side. So I look, on my left-hand side I have a 9x, on my right-hand side I have an 8x. Which one is smaller? Obviously the 8x's, so I'm going to subtract 8x from each side of my equal sign, leaving me with x minus 12 equals 14. Then, SAD-MAG. Do I have any subtraction or addition? Yes, I have subtraction, so I'm going to add 12 to each side, and it leaves me with the result of x equals 26. And again, we can go through and check that. 26 times 3 minus 4 multiplied by 3 will equal 26 times 32 plus 52. Multiply that whole thing by 1/4 and add 1. They will come out being equal. Let's take a look at a couple more examples. The first example we're going to look at is 4 times a quantity 1 minus p equals negative 4p plus 4. So our first step will be to distribute. So when I distribute this 4 over the 1 and the negative p, I will come out with 4 minus 4p equals negative 4p plus 4. Now, going through and looking for like terms, I have none to combine. However, I do have variables on both sides, so I'm going to add 4p to each side of my equal sign. And what I come up with when I do that is 4 equals 4. Negative p plus 4p, negative 4p plus 4p, each one will come out to be 0, so I'm left with just 4 plus 4. Notice in this situation there are no variables. There is simply a mathematical sentence that is true. When you have a situation like this, where all your variables disappear and you're left with a mathematical numeric equation that is completely true, what this means is there are an infinite number of solutions. What that means is that it doesn't matter what number you put in for x, or your variable, in this case p, it will always work. The setup, the original equation, had the same thing written 2 different ways at the beginning. Now, when we distributed, you could see that these are the same, just our order has been changed, but commutative property of addition allows us to do that. So again, if you have a mathematical sentence, an equation, with no variables and the equation is true, then it means you have an infinite number of solutions. Let's take a look at one more. So here we have the equation 2x plus 3 times the quantity 6 plus x equals 4x plus 7 plus x. We'll start with distribution. On the left-hand side, I have 2x plus 18 plus 3x is equal to 4x plus 7 plus x. Next, combine like terms. On the left-hand side, I can combine my 2x and my 3x. Give me 5x plus 18 equal to, on the right-hand side, I can combine my 4x and my x. Give me 5x plus 7. Next, I gather all my variables to one side. I'm going to subtract 5x in both cases. And what that leaves me with is 18 equals 7. Now here, we did all of our work, and we came out again with a mathematical sentence, an equation, that has no variables. But in this case, our sentence is not true. 18 is not equal to 7. So, what this means is that there are no solutions. In terms of what this would look like, and we'll get to graphing at a later time, but if you're familiar with graphing, the two sides of this equation, if graphed, would make parallel lines. And they have different starting points and then travel at the same speed. Well, if you and a friend each leave your own houses, traveling in the same direction, and you go the same speed, you will never meet each other. You'll never get caught up. They will never get caught up. So there's no time that you would be together. That's our situation here. What this hinges on is this part. The number being multiplied by our variable is called its coefficient. If the coefficients on the variables are the same once you've gathered or combined all your like terms, then either you have no solution or an infinite number of solutions. And the difference then becomes what's being added. When we have infinite solutions, we have the same coefficient on the variable and the same constant, number without a variable. When we have when we have no solutions, we have the same coefficient on the variables, but we have different constants. So you should be able to identify those before you get going too far, simply by looking what's the coefficient and then what's the constant. Coefficients are the same, constants are the same, infinite solutions. Coefficients are the same, constants are different, you have no solutions. So if you can keep these straight and keep them in mind with these key ideas, the stars being as you're moving along, the arrow at the bottom, our final display, you'll be able to identify these, and that'll be very important as we move forward. So make sure you have good notes for this, and again, if you have questions, be sure to ask somebody with the experience.